Hello everybody, welcome to MrMiers Math Channel. Today in Chapter 7, we're going to go over Section 7.6, which is graphing square root functions. So we're just going to graph a few simple basic square root functions. Alright, so let's get into it. Alright, first let's talk about the parent function. Alright, every single time we encounter a new type of function to graph, we always want to look at what the parent function looks like and then just make modifications and then just see the changes between the equation of the parent function and this new equation, and then also its graph as well. So usually when we talk about a new parent function, a function of a different type, we use the same input values, or we just like use some input values and experiment and see what the result is, see what those output values is, and then see what the function looks like. So what we're going to do is I'm going to plug in -2, -1, 0, 1, and 2, and then just see what happens. All right, so in the left side of our table, I'm putting -2 all the way to +2, and then we're just going to plug that in, and like I said, see what happens. So we start out with the square root of -2. Now the square root of -2 would be a non-real number. All right, so we're not going to get an output value on the coordinate plane here. If we plug in the square root of -1, we would get I, which is also another non-real number. So once again, this value is not defined at those input values. If we plug 0 in, the square root of 0 is just 0. If we plug 1 in, the square root of 1 is just 1. If we plug root 2 in, we could round that. The square root of root 2 is like 1.14, so on. Let's get some other values that are nice and neat. So we got a decimal value right here. We got some good values that are nice and easy to graph. The primary question that I want everyone to think of is, what would be a good value to take the square root of? All right, and that would be our perfect squares. So for example, the square root of 4, the square root of 9, those would be good values to take the square root of. And that's a question that we're going to ask ourselves in more complicated functions as well. So the square root of 4 would be 2, the square root of 9 is 3, and now we have some values that we can graph and get a picture of this function. So the graph actually starts at 0, 0, and then we go to 1, 1, and so on, 4, 2, 9, 3, and we can graph what this function kind of looks like. So this function looks a little bit different than previous functions, but it also looks pretty similar to other functions as well. If we kind of tilt our head to the side, we can see that we have a parabolic nature there, and for good reason too. Those two types of functions are directly related. The domain of this function, just through experimentation, we can see it starts at 0 and then increases from there. So the domain is x is greater than or equal to 0. And then the range, once again, through experimentation, we can see that it's y is greater than or equal to 0. All right, so this is what we're going to base all of the other functions that we deal with on, the parent function. Okay, so some key things that I want you to think about is what were good values to take the square root of. Okay, taking the square root of 0, 1, 4, and 9 yielded some nice output values that we could graph pretty easily. So if we take a look at the next one, once again, to choose the input values, let's just think, what does x have to be for us to take the square root of those nice values that we had? So what does x have to be for us to take the square root of these values? So in this case, x is going to be our radicand, so we can just choose x to be 0, 1, 4, and 9. So if we plug 0 in, we'll get the square root of 0 plus 2, which is just going to be 2. All right, the square root of 1 is 1, so then if we plug 1 in, we'll have 1 plus 2, which is 3. The square root of 4 is 2, so then we have 2 plus 2, which is 4, and then the square root of 9 is 3, so then we have 3 plus 2 when we plug it into this function, and we get 5. All right, so now we're going to graph this. 0, 2, 1, 3, 4, 4, and 9, 5. Okay, I want to make sure I'm not confusing you on something, which is we're not always choosing these x values, 0, 1, 4, and 9. Okay, those are just nice values to take the square root of. All right, x might not be any of these numbers in some examples. Just for this example, you know, it just so happened we could just plug in those x values and we would get the square root of 0, 1, 4, and 9. So based on our function then, our domain is x is greater than or equal to 0. We can see it started at 0 and increases. And then correspondingly, the range or the output values start at 2 and increase, which makes the range y is greater than or equal to 2. All right, so at least for the range, we can see the correlation between the equation and the output values. That plus 2 directly affected the range, which makes sense because that plus 2 is happening to the overall function, which means it's affecting y, okay, which would be our output values. If that plus 2 is inside and part of the radicand, then it would be directly affecting the domain. Okay, so now let's move on. All right, in the next one. So once again, another really simple one, but that's okay. We can choose our input values to be 0, 1, 4, and 9 so that we can take the square root of 0, 1, 4, and 9. So 2 times the square root of 0, just like anything times 0, it's just going to be 0. All right, 2 times the square root of 1, which is 1, is going to give us 2. 2 times 2 here would give us 4. 2 times 3 would give us 6. We can see the domain is x is greater than or equal to 0 and y is greater than or equal to 0. All right, so now let's graph that. 0, 0, 1, 2, 4, 4, and then 9, 6. All right, not the best graph in the world, but we get the point. All right, so let's move on. All right, so in the next one, we can't just choose 0, 1, 4, 9. All right, if we choose 0, then we'd have 0 minus 1, which would give us the square root of -1, which we can't plot on our graph. All right, so in this case, this comes back to the question, what does x have to be for us to get 0, 1, 4, and 9? To answer that question, all you need to do is set that radicand equal to 0, 1, 4, and 9 and solve that equation. So what I mean is, set x minus 1 equal to 0 and solve for x. So we would add 1, so that's our first input value. All right, set x minus 1 equal to 1 and solve for x. If we add 1, we'd get 2. So if x is 2, then when we plug it in, we have 2 minus 1, which means we're just taking the square root of 1. All right, so x minus 1 equal to 4, and we get 5. And then set x minus 1 equal to 9, and we get 10. So by plugging in these values, we'll be taking the square root of 0, 1, 4, and 9. All right, so we got our input values and our output values. So let's plot those. And now graph our function. All right, so the domain is the set of input values, so that would be x is greater than or equal to 1, and then the range, y is greater than or equal to 0. So in this case, the range was unaffected because we didn't have anything adding or subtracting to the overall function, like at the end outside of the radical. And the domain was affected because that minus 1 is directly affecting x. Okay, it's directly manipulating our input value. All right, let's move on. All right, now you should know what to expect here. That minus 1 is happening to the overall function, so that means we're going to have some decrease in the range. Okay, so we're going to plug 0, 1, 4, and 9 in. Okay, and then we have the square root of 0 minus 1, which is -1. The square root of 1 minus 1, which is 0. The square root of 4 minus 1, which is 1, and then the square root of 9 minus 1, which is 2. All right, so that means the domain is x is greater than or equal to 0, y is greater than or equal to -1. And let's plot those values and see what this function looks like. All right, so it's just like the parent function, except it's stepped down, just 1 unit. All right, last one. Finally. Here we go. We got a couple things happening in this function. Is y equals -2 times the square root of the quantity x plus 2. First thing that we need to do is figure out what what input values we need to use. So what we're going to do is set the radicand equal to 0, 1, 4, and 9, and then find those x values. So x plus 2 equals 0. If x plus 2 equals 0, then x equals -2. If x plus 2 equals 1, then x equals -1. If x plus 2 equals 4, then x equals 2. And then finally, if x plus 2 equals 9, x equals 7. So we've got our input values that are going to yield some nice and neat output values in general. All right, so now let's plug that in. So if we plug in -2, we already know we're going to get the square root of 0. So this is just going to be -2 times the square root of 0, right, which is 0. And then for the others, it's just going to be -2 times the square root of 1, 4, and then 9. All right, so that's -2 times 1, which is -2. -2 times 2 is -4. -2 times 3, -6. All right, so the domain is x is greater than or equal to -2, and the range is y is less than or equal to 0. All right, so now let's plot those points. -2, 0, -1, 2, or sorry, -1, -2, 2, -4, and then 7, -6. Awesome sauce, folks. All right, so that's it. If you enjoyed that, if you found that helpful, please like, subscribe, and share. Thank you, and have a great day.